All right. All right, any questions on chapter 28?
Number 82.
82. All right, so we're given a conducting material resistivity, shaped wire like a cone, length L. Current density of the wire constant as a function of the horizontal distance x, resistance of the shaped wire. All right. So I know current density is basically dADI. So that is a constant. DI A, I think I said it back. The area, given our code here, and some radius r, is equal to pi r squared. Di equals JDA. And so, I forgot what they have to give. Oh, they're asking for resistance. Other markers. Here we go. At least get the bits down. So this is R1, R2. L is that length right there, and I'm going to define X to be basically from the left-hand side. I know that resistance, let's see, with the resistivity rho, okay. Resistance is rho L over A. And so we want resistance of the whole thing. All right, so as we start moving our way across here, I know that my area is changing as we go. I know, well, L is basically going to be my variable X here. So we have R is equal to rho, I guess dr, rho dx over A. A is a function of X, depending upon where we are on the spectrum. So this would be rho integral, my notation's horrible there. So my resistance should be the integral, rho times the integral of dx over A. So the big question comes down to how is A a function of X as we move across, and X are going from 0 to L. Sure I haven't gone too far astray here. Okay. I know that the area is pi r squared as written right here, so the question is, what is r as we move along here? And, well, basically I have a slope. I start out at R1, I end up at R2. So if I just plot my radius versus x, I start out at R1, I end up at R2, at position L there, and I basically have a function which is going to describe the relationship between R and X. So R is equal to, well, slope, rise over run, negative R1 minus R2 over L. It's my slope times my variable plus my intercept. We can distribute the minus sign to Depends on how you wanna deal with minus signs. So this becomes R2 minus R1. Oh, yeah, that's right. Over L times X plus R1. And now, plug and jug. And one of these markers will be dark enough. I think I tried that one already. So this becomes rho times the integral of from 0 to L dx over that squared. R2 minus R1 over L x plus R1 squared. And then we just do U substitution. U equals R2 minus R1 over L x plus R1. Du equals R2 minus R1 over L dx. And so this becomes, I got this constant right here. So we got L over rho, rho L over R2 minus R1.
Where was he pi?
I did lose a pi. Thank you. Is that it? All right, thank you. Times U squared. From, we plug in 0, we get R1. We plug in L, and we get R2. Since I changed from differential to U. And so we have rho L over pi, R2 minus R1, negative 1 over U, R1 to R2. Yep. And then rho L over pi, R2 minus R1, negative 1 over R2 minus negative 1 over R1. And so this becomes R2 minus R1 over R1, R2. That seem right? Yeah, feels right. Negative. And now, and then that drops down. And now we just get rid of the stuff that we can. And we got a pesky minus sign there.
I think this is where you define your R1, R2. When you define R at least.
So when X is L, that would cancel out. I'd have negative R1 plus R2, so I should have R2. That, you say this is where you think the problem was?
Yeah, that negative sign shouldn't be here in front of the R1 minus R2 because that would make it, yeah, since R1 is bigger than R2.
But as I progress, I'm getting a smaller radius as I move to the right. My radius is getting smaller as I go.
But wouldn't that account for it? Because R1 is your max value that you can have, and then as you progress, that
Oh.
starts to decrease.
That's actually not the mistake. The mistake is oh no, I did stick that in there. All right, what's your argument, Mario? Sorry.
So like R1 is your max value.
Right.
And as you're progressing, because your R is basically your Y component, and then as you progress towards the right, you can't get any bigger than R1, and you can't get any smaller than R2. So R1 minus R2 is correct, and then, so you wouldn't need that negative sign in front of there.
All right, but if we stick L in here, so when X is equal to L, so we're here.
Okay.
If I stick an L in there, the L's will cancel. And what I would claim is we'd have negative R1 minus R2 plus R1, which is negative R1 plus R2 plus R1, and I'm left with R2. If I took that minus sign out, I'd have to R1 minus R2.
Oh, yeah, I didn't see that one, plus R1. What if you did plus R2? Then that would that deem, R1 minus R2 valid?
Yeah, you're basically establishing this and going, I guess, that way. But there's a minus sign messed up somewhere else. Because I distribute the negative sign and then flip that to R2 minus R1. And then we have, oh. No. When I stick in, because we're going from 0 to L, I put in a 0 here. And I got R1, put in an L here, and I got R2, that's right. L, so when I flip that over, so that's an R2 minus R1 there. D over U squared. It's probably just something silly here. Oh. Yeah, I've got a note here where I scratched out the plus sign they have and put in a minus sign. However, log it up here. So u to the -2, you add 1, divide by -1, okay? So that's right. So this is 1 over R1 minus 1 over R2, which is R2 minus R1 over, oh, that's the mistake. So I get rho L over pi R1 R2. Do you feel a little bit more complete?
Yeah.
All right. Yeah, other questions on this? And this is what happens when you take shortcuts and do it all in your head. Or I guess I should say, this is what happens when I take shortcuts and then do it all in my head. Other questions?
Number 33.
Yeah, that's a lovely one. All right, so ultimately we're trying to find the current. So we have spherical shells. Radius A, radius A, radius B. A equals 4 centimeters. B is 0.08 meters. There's a 2-volt difference between the two. Inner sphere has a charge Q. All right, the way they've drawn it is the current, presumably, I assume that's what the arrows are indicating, that the current is flowing outwards. Now, right off the bat, since we know the current is flowing from the small shell to the outer shell, between the two shells, which one has a higher potential?
Middle shell A. Middle shell A.
Okay, and
Wait, so you said which one has the highest potential?
which has the higher potential?
It's electrical current, right?
Yes.
Low to high, so the outside. High to
Goes
low.
high to low. Current flows downhill. I mean, that's ultimately Ben Franklin's thinking, from high to low. So, yes. All right, so this is, so whatever this is, they tell us that the potential difference is 2 volts, but the current's gonna be flowing from here to here, so the current's gonna be undergoing -2 volt. They don't specify that, you have to sort of draw the conclusion based upon the mysterious blue arrows.
Can you, flip it though? Like, would you be able to say from VA, or from VA final minus VB final, or VB initial, and then that would give you a positive 2-volt difference?
Wait, say that again?
So, say you're flowing from B to A instead,
Okay.
and wouldn't that give you the potential difference of, 2 volts positive?
Oh, yeah,
If you didn't wanna work with the negative, I guess.
right. Since we're trying to find current flow, it generally, well, it could just be a philosophical difference. I mean, I want to go in the direction of the current flow,
Okay.
ultimately. All right, so if I look at Gauss's law, I know the integral through some closed surface, E dot dA, is equal to the charge, the enclosed charge over epsilon sub naught. So Gauss's law of electricity. They jump through a couple extra steps in the solution to get to this exact same point. First off, why epsilon sub naught? Because I've got filling inside here. Let me read the question for those who don't have it memorized. 2 concentric metal spherical shells of radii A equals 4 centimeters and B equals 8 centimeters are separated by aluminum as shown in figure 28.33, which looks just absolutely amazingly like that. The inner sphere has a total charge Q at any time. If the 2 spheres are maintained at a potential difference of 2 volts via an external source, otherwise known as magic, calculate the current from one sphere to the other. Why can we justify epsilon sub naught when I got something touching these 2 spheres?
Is it because of the charge inside of A?
I mean, if I have 2 parallel plates, they're charged.
Is it because it's not a dielectric?
Say it again?
Is it because it's not a dielectric?
Exactly. It's not dielectric. All right, so we have this charge flowing out. I know that my electric field inside here is, well, my enclosed charge. Basically, I've got spherical symmetry here. So we could go with this, or ultimately, my electric field is going to be K, or 1 over 4 pi epsilon sub naught, times Q, which is the charge on this inner sphere, over R squared R hat. Okay, lots of notes written in the margin here. So current is equal to, they're basically going with a current density to start out with, JDA. Sort of one of those false starts from the previous problem, that current density is basically A over I or DI over DA, or DIDA. Then we get into another definition of current density, which is basically sigma times E, that what I think of as the Joe formula. Current density is sigma, the conductivity, times the electric field. No, wait, that current density is not a vector. Magically going to put a vector into it. Since I want this to, since we are looking at current flowing outward in this sphere, we can look at this basically over the area of this Gaussian sphere that we put somewhere in the middle here. So we're left with sigma times Q over epsilon sub naught. Now I didn't write enclosed because Q is actually defined in the problem as the enclosed charge, or at least the charge on the inner sphere. Questions to hear? All right, we need to figure out what the charge is in terms of other things. Now, I know what the potential difference is between the two spheres, and so basically, we're going to look at that relationship. I know that the potential difference is equal to the negative integral of E dot dr, which is the negative integral from A to B. Well, my electric field is in the direction of which we are integrating. I'm going from this inner surface to the outer surface, from A to B. So my electric field and dr are in the same direction, and so we easily get rid of the dot product, and just 1 over 4 pi epsilon sub naught Q over r squared dr. Pull the constants out. Negative integral, pull the constants out, try that again, over 4 pi epsilon sub naught, integral from A to B, r to the negative 2 dr, which is negative Q over 4 pi epsilon sub naught, r to the negative 1 over negative 1, from A to B. And so we get Q over 4 pi epsilon sub naught times 1 over B minus 1 over A. And that should be equal to negative 2. Let's do a double quick check here. I know B is larger than A. Therefore, 1 over B is smaller than 1 over A. And therefore, this binomial here is negative number, so the signs are going to work out. Which, in my case, considering how often I mess up the signs, it's good to check every once in a while. So this piece right here becomes A over A minus B over AB. Make sure I didn't mess up like I did the other time. Let's see, so multiply A over A times D over B. I'm good with that. And so Q, which is ultimately what we're trying to find here, is equal to negative 2 times 4 pi epsilon sub naught AB over A minus B. And now we can come back over here to find current. That spectacular finish, green. And so we get sigma times negative 2, 4 pi epsilon sub naught, AB divided by epsilon sub naught A minus B. Epsilons go away, and now it's a plug and chug exercise. And conductivity is the reciprocal of the resistivity, so, or you can just look it up in the table. I'll just go straight to the solution. They have 3.767 times 10 to the 7th. And that's per ohm meter times negative 2 volts times 4 pi 0.08 0.04. Those are both meters. Divided by 4 meters minus 8 meters, or 0.04 meters minus 0.08 meters. So ultimately, this negative sign will cancel out with that negative sign, so we're good there, and it's a calculator exercise, and according to my notes, their answer is correct, 7.6 times 10 to the 7th amperes. Because Austin, you the one kicked that off. Do you feel better as a human being now?
Yes, I feel more complete.
All right.
Sorry,
The rest
can
of you,
can
sorry. Pardon?
Sorry, can you repeat why it's negative 2 again?
Because current flows from high potential to low potential. So if I have current flowing that way, assume from the basis of the arrows that they drew, the current is flowing from the middle shell to the bottom, to this shell over here, that this is the higher potential than that is.
Oh.
All they say is the potential difference is 2 volts. They don't specify which way you're going. Also, if I treat it as a positive 2 volts, we'll end up with ultimately a negative current, which means it's going the other way. Now, if it turns out that Q is a negative charge and current is flowing towards it, then that will show up. Oh, I guess that would show up here. That would suddenly become +2. Other questions? Yes. That's more complicated than either of these. It just felt like a fun little problem. I hope you enjoyed it. All right, other questions before I hand this out? I'm gonna do something crazy and start at this side. Woo.